Hello everybody and welcome to a brand new tutorial series on Scratch, and today we'll be taking a dive into coding an arcade classic, Pong. Let's load up Scratch and create a new project, and let's get coding. The first thing we should do is name our project Pong, as we want to know what to look for when coming back to this project. The next thing we want to address is what our game looks like to start. We don't want a cat in our Pong game, so delete all the costumes but keep the sprite. Then click into the backdrop sprite and draw a rectangle to fill the screen black, since that's the color of the background in Tennis for Two. Now draw a white line with a width of about 10 from the top to bottom. The line doesn't have to go off screen. You can keep the edges on the screen if you like. But please make sure the line is centered on the canvas, since it's supposed to be the middle marker in-game. Now click into our empty sprite and name it Paddle. I think you can guess what this is for. In the costume editor, make a vertical white rectangle and make the size around 10 by 64. Got it? Good. Let's do some coding. When green flag clicked, go to X -220, Y 0. You can change the X value to whatever feels comfortable. For the paddle movement, we can do this in one of two ways. We can use the mouse cursor's Y position, or we can use the arrow keys. The first one I want to show you how to code is the arrow key movement. So add a forever loop and an if check. If the up arrow key is pressed, then change Y by 5 or whatever value feels right for you. Let's give that a test. And it works. We can move our paddle up. Now let's move it down. Back in the code, duplicate the if statement we created and make it for the down arrow instead of up, and change the 5 to be a -5, or whatever number you had, into a negative number. Let's test again, and we now have full control of the paddle's movement. But we can go past the edge, and we don't want that, so let's keep coding. We need to find the bottom edge's Y position on the paddle by using the bottom Y value, which is -180. And we add half of the paddle's height. We can check that in the costume editor, and it says 64, and half of that is 32. So in the code, add an addition operator. Put -180 on the left and a division block on the right. For the left of the division, put in 64, the paddle's height. And on the right, we divide by 2, since we need to cut it in half, or 2 equal pieces. Click the block and we should get a number close to -148, depending on your paddle's height. Remember your number. So since the height of the paddle won't change in-game, we can just add the number manually rather than an equation. Add an if statement with a less than operator inside the condition and a Y position block on the left. We will check the bottom edge first. So on the right side of the less than, add the answer we got from earlier. And mine was -148. So if that happens, add a set Y to -148 or whatever number you got in the if check to reset the position of the paddle when it goes off screen. Now let's compensate for the top edge. Duplicate that last if and replace all the negative numbers for positive numbers and the less than for a greater than. We can give that a quick test to make sure the collisions are working properly, and they are. Now I'm so sorry I had to keep you waiting for the mouse controls code if you wanted to add that, so let's do it now. So we need to keep in the collision code with the mouse controls, so make sure you have that added in. The actual controls are super easy. All we need at the top, before the if statements, add a set Y to mouse Y. We can test that, and now the paddle should be following your mouse cursor with proper collisions on both the top and bottom. I personally like to use the arrow keys control scheme, but you can go either way. It'll just be easier to add a second player. So now that we have good paddle movement, we can move on to adding the ball. Make a new sprite and name it Ball. Select the paintbrush tool and just draw a dot with a pen size around the same as the white line in the middle. So for me, it's 10. I would recommend making it slightly bigger though. Anyways, click into the code tab. When green flag clicked, go to X0, Y0. Now for the starting direction. You may think you would just point in a random direction, right? But that can lead to super easy levels. So the way to fix this is pointing in any diagonal direction. That is, pointing towards the top left, top right, or bottom left. Let's code that. Point in direction. In some free space, add a pick random from -1 to 2. This can give us any direction. -1 for left, 0 for up, 1 for right, and 2 for down. So we need to multiply these numbers by 90, so add a multiply by 90 and put the pick random inside the left side. Now we can get -90, 0, 90, and 180. But we want diagonals, so add 45 to the result, and put everything into the point and direction block. Now, just for testing, to make sure it's working, I'm going to add a temporary line to the right of the ball in the costume editor so we can see the direction it's facing. Now click the green flag. Again and again, it's facing different diagonal directions. That's exactly what we needed. So now, delete the line and name the costume ball. And let's get the ball rolling, no pun intended. Forever, move 10 steps. This could be a little too fast for some people, so make it 5. Click the green flag, and whoosh, it's off. But our ball is looking sticky, so we need to make it bounce off the walls. Add an if less than. If the y position is less than -177.5, this is -180 plus a quarter of the ball size, which is 10. Next, we need to check the direction, so add an if else inside the if, checking whether the direction is greater than 0 or not. This is just checking if we are going left or right, so we can turn the direction away and into the walls. If the direction is greater than 0, then that means we are moving to the right and we need to turn left by 90 degrees. So add a turn counterclockwise by 90 degrees in the first branch. Otherwise, we are going left and we need to turn right by 90 degrees. So add a turn clockwise by 90 degrees in the else branch. We are free to test, so smash that green flag. Okay, here we go, and success! We bounced the ball. And what about to the left? Perfect. It bounces off the bottom edge with ease. We don't need to worry about the left and right edges in this episode, but we need to work on the top edge. So duplicate the outer if and put it underneath the first one. First of all, we aren't checking the bottom edge being hit anymore, since we already did that. So let's replace the less than for a greater than and the negative number for a positive number. So if the y position is greater than 177.5, then check if we're facing right or left. Since we are working with the top instead of the bottom, the directional changes are flipped. So bring back the turn block from the else into the if, and put the first if into the else. And it works. We can safely bounce off the top edge. But we can't bounce the ball back at the other player. It just goes right through the paddle. So still in the ball sprite, way at the end of the forever loop, add an if. Check if the ball is touching the paddle. Then add an if else, checking if direction is greater than -90. If we are, then we need to turn clockwise by 90 degrees. Otherwise, we need to turn counterclockwise by 90 degrees. Run the project, and we can bounce the ball on the paddle and walls like we are actually playing Pong. Except we don't have a second paddle to hit the ball back to us. What do we do? Should we add a computer as a paddle or a second local player? Let's go for the second local player since we will have more control. So click onto the paddle sprite and rename it to player, then duplicate it. We now have a player 2 sprite, but the name fits, so I won't change it for now. In the player 2 sprite, change the up arrow to be the W key and the down arrow to be the S key. Then to put it on the right side, set the X position at the start to +220 instead of negative. Now run the project. You can control the player on the left with the arrow keys and control the player on the right with WASD. And what? Why is the ball not hitting the paddle? This is actually normal. It's a quick fix. Just click into the ball sprite and it should be fixed. Scratch only updates code when you are currently inside the sprite. So just check, and now the touching check is for the player sprite, not the paddle sprite, which doesn't exist anymore. But I won't, since we should add collisions for the other paddle. To do that, bring out an OR condition. We want to check if the ball is touching either player 1 or player 2. I've actually renamed the original player 2 sprite to player 1 and player to player 2. Then I switched around the X positions. Why did I do that? It's because of the keyboard layout. Anyways, click back into the ball sprite. Let's make a new custom block to hold the ball collisions. Name it bounce off paddle and run without screen refresh. Drag the if direction is greater than -90 condition inside the touching check and bring it under the new custom block. To make it run, drag the block into its old spot under the if touching. Now, even though we are already checking if we are touching a paddle, we don't yet know which one. So under the defined bounce off paddle, surround everything with an if else. Check if we are touching player 1. If we are, then we will run this code. In the else branch, duplicate the if statement from above. Instead of checking if the direction is greater than -90, or facing to the top left, we need to check if the direction is greater than 90, or facing to the bottom right. Run the project, and if you followed this tutorial correctly, everything should be working fine. And that brings us to the end of this episode. I hope you enjoyed watching this video. If you did, then smash the like button and subscribe to the channel. If you'd like to ask a question, offer a video idea, send a video for me to react to, play my complete games, and so much more, click the link in the description to visit my website. So have a great time coding future projects or doing whatever, and I'll see you next week. Bye.